Problem 51 asks you to refer back to an example in which Linda has two different distributions for her sales at her dealership, one for cars and one for trucks. That example went through how to calculate the mean of a probability distribution by hand. Now that you know how to use your calculators, you're going to do that in order to find the standard deviations. So some of this information I pulled from the examples. The mean of the cars is 1.1. The mean of the trucks is 0.7. In order to find the standard deviations, similar to what we had done in the last problem, I put the different values that the random variable can take on in my X list. So for cars, it was 0, 1, 2, 3, and for trucks, 0, 1, and 2. Their associated probabilities, calculate the one-var stats, and you should come up with these means and standard deviations. Part A also asks you to find the standard deviation, not just the standard deviation, but also the variance of the sales for the trucks. So that would be squaring the standard deviation, and if you're rounding to 4 decimal places, you should get about 0.41. When we move on to Part B, it says because car and truck sales are not closely linked, Linda is willing to assume that car and truck sales vary independently. So this is really important that they are independent. That allows us to combine their standard deviations, which it asks us to do as we continue on with this part of the problem, Part B. So to obtain the standard deviation of the total sales, which is their sum, we'll take their variances, add them together, and square root the final answer. When we take the standard deviations, square them, add them together, square root, we get about 1.1403, and we want to, as always, put our units on the end here. Because we're talking about cars and trucks combined, we're just going to call them vehicles. Part C now asks for the standard deviation of Linda's estimated earnings. The examples that we refer back to found the mean of her estimated earnings, and it used this formula in order to calculate that. So this is her commission on each car, $350. This is her commission on each truck, $400. So then her total earnings would be the sum of each of those. So again, refer back to the example if you'd like to take a look at how the mean is calculated. In terms of the standard deviation, we're going to use two processes here. What we use when we add two distributions together, and then also what happens when we multiply by a constant. So we'll add the variances together, square root, just as we have been doing, but we also need to multiply by both of these coefficients, 350 and 400. When you calculate these, I want to make sure that you're squaring the 350 and the 400 along with the standard deviations themselves before you take the sum and then the square root. So the rest of the calculations will look like this. We'll take 350 times, let's see, what's our standard deviation of x? 0.9434. 400 times 0.6403. Square those entire quantities, find their sum. Because we're talking about earnings here, our units are dollars. Her standard deviation is about around $420 per day, which is pretty variable. That's a pretty large swing to have in any given day. And that wraps up 51 in terms of what the book asked us to do. I am going to move on to one more slide here just to show you one last concept, some questions that I've received in the past. A couple years ago, a student asked me why we weren't doing any normal calculations with this problem as we did with the circuit problem in the ohms. The answer to that, first and foremost, is that we are given a discrete distribution here. Linda can only sell a whole number of cars or trucks, and since the normal distribution is a continuous distribution, we can't use the continuous distribution or concept to describe this discrete case. We sometimes use the normal distribution to describe a discrete probability only if the discrete distribution looks semi-normal, and there are some other qualifiers that you're going to learn about later on in the course. So what I wanted to do was make a quick histogram of these two distributions to show you why it wouldn't make sense for us to use normal calculations in this case, in addition to the fact that we have a discrete distribution, and again, normal is continuous. So if I take the cars, we can take on the values 0, 1, 2, 3, and I list probabilities here on the y-axis. If I draw my histogram, so I think the probability of 0 was 0.3, 1, 0.4, 2, 0.2, and 3 is at 0.1. We see that this distribution certainly does not look normal. It's not bell-shaped, it's not symmetric, and in that case, a normal calculation wouldn't make any sense. The scenario for the trucks is even a little more obvious. For 0 trucks, we have a probability of 0.4, for 1, 0.5, and 2 down here is all the way at 0.1. So in that case, a normal calculation wouldn't make sense either. Just wanted to kind of highlight that, since some of the other problems had us doing normal calculations and this one did not. And that's it.